would invite all our guest speakers to start with the panel discussion on aerospace and defense manufacturing, enhancing self-reliance. So my first question is, how is Make in India initiative impacting the aerospace and defense industry in India? Is it time to reassess manufacturing automation in aerospace factories? I would like to start with Mr. Joseph.
You asked the right question because in today's scenario, we have seen with the war happening in different parts of the world, without self-reliance, without expanding our manufacturing base in our country, no country can survive today. So I travel across the globe. We are seeing huge investments happening, and India is at the right time. If you ask me today, our manufacturing in defense is about 1 lakh crore. We expect that to touch in next 2 years about 1.75. Look at the massive growth, and the government has set up about 35 crores target for the next 2 years, which is at about 13 crores right now. So that's the pace at which we're growing, and we are at the right time where automation, 3D printing, all kind of advanced technologies, it's the right time to induct into, because OEM is slowly picking up. We are at the right time. Thank you.
Thank you, Mr. Joseph, for sharing your insights. What is your opinion, Dr. Kiran?
Thank you for the invitation first. It's actually nice that India is, going towards enhancing the self-reliance, especially in the aerospace sector, which is, vital as a budding nation from this perspective. But India, in addition to, as part of this activity, is also doing a lot of developments aiding to these sectors by catering to the needs of the investment in R&D activities of these sectors. It is also trying to enhance the skilled workforce development. It's also trying to do the infrastructure development, which is vital for the country. It's also trying to introduce a lot of public-private partnerships, which will also encourage domestic suppliers within the country towards self-reliance. It's also creating new or completely unforeseen regulatory reforms, like, for example, as it has done for the space sector. It's also giving good sort of export incentives, or foreseeing good export incentives. And it's also enabling international projects, and also giving us a lot of respect in international projects throughout the world. It also takes, as of now, significant amount of interest in terms of cybersecurity measures, although some cases have been reported. And it's also trying to establish localized clusters of excellence. And it is in the process of enhancing the ecosystems of various topics in addition to aerospace and defense, and also creating access to the capital. Through these, I think India is on a good shape, driving the entire aerospace and defense ecosystem.
Yeah, thank you, Dr. Kiran. A lot of new windows are opening with Make in India concept. What is your feedback, Kritika?
I would like to thank the OEM update for inviting me to this webinar, first of all. I think that this self-reliance is very important. So especially if you take the sector that I am coming from, so we belong to unmanned aerial vehicles and drone technology related services. So there you see this self-reliance is still in a developing state. So government is offering a lot of inputs and support in the form of conducting certain expos like Drone Mahotsav and many other, Convergence and lot of other expos. So when they conduct this kind of gatherings and expos, we'll be able to get some good contacts who are inside India as well as internationally for getting the technology to next level. So apart from this, even there are a lot of funding opportunities and mentoring opportunities from Department of Science and Technology. So not only Department of Science and Technology, even in other government bodies are also offering the same. So in that case, this self-reliance is very important, and we are moving towards that goal. So that's what I would like to submit from my side.
Thank you, Kritika. Lot of sectors are opening up with self-reliance. Mr. Amardeep, what are your suggestions about Make in India?
So to begin with, I think as a country, manufacturing is not new for us. India has been manufacturing nation for many decades. But it's always that manufacturing is happening in few sectors, which more of, I would say, low technology sectors. And at the same time, what Make in India has done is the people within the country, but the whole world is looking at it as a new India now. So that is what as Make in India campaign has done. And at the same time, the great thing what we're seeing is every company, every manufacturing company or every OEM, every design house, wherever we go, we see that everybody puts some kind of emphasis on Make in India. So be it 10%, be it 5%, whatever they make. So to me, more than like creating new manufacturing things, which has already happened, what Make in India has done is that has created a new wave and the new direction for the whole country, that we are going to get into manufacturing for much larger advanced sectors, and aerospace is one of them for sure.
Thank you, Mr. Amardeep. A lot of opportunities are opening. India very recently has achieved a feat of landing its Pragyan rover over moon at the South Pole. So how efficient component manufacturing and the uses of sensors have progressed with this Chandrayaan 3 mission? Let me start with Dr. Kiran.
Indeed, it's an honor actually to speak about Chandrayaan 3 or any of the landing feats what has been achieved by our country, propelling the entire country to greater heights. First of all, I would congratulate each and every family member and member of the Indian Space Research Organization for this fantastic feat of putting us onto the global map of space at a very, very high position. And it was simply excellence which has been showcased there. The meticulous ways in which manufacturing is done in the space sector involves a lot of reliability and reproducibility to the highest order of precision. So in this process, aerospace and defense sectors, both of them, have a lot of precision manufacturing involved in that, with a lot of reliability, which is very important. Otherwise, you already know many cases of history where most of the people already know many cases of history where things have failed in the space sector or in the defense sector because of some minor issues of manufacturing or minor issues of mistakes happen, but they are very costly in the aerospace and defense sector. So manufacturing plays an extremely critical role, and building the next generation is also equally important when we consider the way in which Chandrayaan has achieved its feat, where India has been constantly pursuing the space technologies since its inception in 1960s, where, for example, we see the case of Russia, where we unfortunately had, at the end of the day, a space mission which is at loss is lost to the world. A huge amount of technology has gone at the end, although we can say on one hand we are the fourth country proudly, but the loss technologically is a significant loss to the entire world in terms of getting knowledge. So I think failures are part where one has to learn in the entire thing. But at the same time, aerospace is very, very stringent, because once man or any object goes into space, space is simply ruthless. Then
Definitely.
no one hears our word of help over there.
Definitely, Dr. Kiran. Mr. Amardeep,
Sure.
what would you like to say upon it?
Yeah, I mean, one of the proudest moment in terms of technological feats, being an Indian, for sure. I think this is something that the kind of interest that space has got is very, very positive for the whole country, because I think after cricket, we haven't seen such kind of interest from every part and corner, and a common interest for the whole country. So that's a great thing to see, that people are celebrating technology successes, not just sport or cricket. That's amazing for the country. And coming to what that really means for us as a country is, like Dr. Kiran said, space is something that is very cruel, and it's extremely difficult to get systems to work right. And particularly in this mission, what we can see is right from the time where GSLV has lifted off, and right from the time where the rover has landed. If you just look at sheer number of technologies, just forget about the mission or anything. Just if you list down the number of technologies that goes in there, that itself is going to be a massive list. And what this is going to say is we have actually achieved success in all of these technologies to make this whole mission a success. And at the same time, what confidence that it really gives is the knowledge of all these still exists in India. So that's the biggest thing that I'm taking away from this. So it's all about the knowledge of people, and it's all about the attitude of being able to achieve these things even after a failure that happened 4 years ago. So working on something that has failed, and again working on it for 4 years, day and night, is not a small thing. So with these things, we should be able to achieve anything. So it's just that how we channel the knowledge that we have in the country, and how we channel all the energy that we have with the young population. That's the whole thing that we need to make even greater things happen.
Thank you, Mr. Amardeep. Yeah.
Probably I'd like to add a sentence.
Yes.
Being in the fact that all of these are strategic sectors of the country, in strategic sectors, all these technologies, whatever we employ, are having not dual use, but actually multi-use. So multifaceted use, which aid every field of engineering or science. So one has to also note this point.
Definitely, India has got a new direction for the engineering and technology achievements. Mr. Joseph, what is your views about this Chandrayaan mission?
I think they already covered, but I would add another 2 points.
Yes.
One is, ISRO as an organization mastered the systems engineering domain end to end, and that is something which I found missing in our country. We went behind the IT revolution, but then this overall engineering systems building capability is something they mastered it. And on the top, I see a work culture there. I work very closely with them from throughout my career. They put the most powerful people in quality and reliability area. In many other organizations in India, it is a punishment transfer, right? So here they put the most powerful people. They can overrule anyone inside. So that's the first thing which we should do, that, put the quality in the first phase, do it right always. That will pay off on a long-term basis. Now, the other aspect is, again, linking to business. We always talking about scalability in manufacturing, but in the lower end of the manufacturing chain, we always have a disadvantage because being a late entrant. But in high-tech manufacturing, it's a different game where trust plays a major role. We are in a better position in the global supply chain in terms of creating the trust and credibility as a reliable vendor. So that is something I think we could focus more on high-tech manufacturing. Of course, we also need some low-tech, low-end manufacturing, but then this is an area where we can master it. Now, very specific to ISRO, where I see the ball game moving is very soon you will see all these regular firing rockets, any reusable technologies, all will be moved to private. ISRO will be probably focusing more on the core R&D. And that throws open to a lot of opportunity for the private sector. A lot of private companies are already working with ISRO, but I am seeing a lot of new entrants, entering into this space. That will be a huge opportunity. The whole ball game of what is happening right now in the defense sector will move slowly. It will take maybe more time in space to happen. Probably, but the learning now what we are getting in defense industry will be the game changer for space industry. We are learning a lot. When we are moving this transition from a pure government, design, manufacturing, business oriented to private, public, Indian versus Indian, global, Indian, in India itself, private, public, all kind of combination are getting tested now. And this is a maturity phase. We are learning a lot. I'm sure we are in the right direction.
Yes, definitely, Mr. Joseph. Rightly said. R&D and high-tech is the priority now. What is your opinion, Ritika?
Yes, sir. So as Joseph sir was telling, I just see this as a beginning of a big journey in India, because we have opened our arms and we are joining both the government and private sector together for all these technologies. So that's what I see as a huge potential and opportunity in terms of this Chandrayaan mission as well as any other technological mission. So it is really important that both the sectors should grow. Government as well as the private sector must be growing. So the initiatives of ISRO bringing in the private sector into all the spatial missions is, I think, the key factor, which is letting them shine in this space sector.
Rightly said, Ritika. Public and private partnership has to come into being now. Dr. Kiran, what is your opinion about AI-based products used for maintenance of aircraft components?
AI-based products are actually excellent way of reducing the time in getting a product out. But effectively, what happens is that the human brain also is much better, or rather much better powerful than that. Utilizing this in combination with an AI-based product, it's very, very critical in the current scenario where AI is developing. At the same time, the traditional ways in which humans think are not yet to the extent of completely relying on these AI-based products in the manufacturing, especially in the defense and the aerospace sectors. Of course, we can go to a significant level of trusting the AI-based products, but especially when people are thinking about the point of everywhere, whenever we say AI-based product, people get excited. And a lot of people, students are propelling towards this fact of going for AI and computer science, but rather leaving the core branches of science and technology or engineering, which is actually going to affect us significantly in the forthcoming years because of this mindset, probably of the students or probably of the parents who are directing them in an unknown field, but effectively affecting the forthcoming generations of the country.
Thank you, sir, for sharing your opinion. Mr. Joseph, what software testing and analysis regulatory standards could be developed to verify the components' quality during imports?
It's a big question mark, because when something is getting imported, no one discloses what is there inside, right? And today, if you look at the high-tech business across the globe, people are parking their IPs around software and electronics. They're ready to outsource your mechanical parts to anybody. They don't mind you copying your mechanical. So all the major players are parking their intellectual property around electronics and software. It could be a trap. And as a country, this is where I repeatedly tell in all the forums, if we don't become self-reliant in this area, at a time when we really want to use a system in a given context against a particular country, the party who supplied the system will say, no, you can't use it now. And you try to use it, it may not work in a given context, in a GPS environment, when in that particular coordinate, your weapon system may not work. That's the way today's systems are getting built. I'm not blaming anybody, but as a country where, when I want to protect my country's strategic interests, I would try to reduce the dependence on imported high-tech things, because all of them sign a document saying that there is no malicious content, there is nothing. But then I don't trust anybody. In today's this business, I don't trust anybody. And for the same reason, as a country, we should expand our capabilities in this space, build indigenous capabilities. And this is especially in the cyber space. Cyber is a dirty world. I'm in the middle of that business. That's what I'm telling you. It's a dirty world. So we need to be more careful on that aspect. It is not about having a toy on the shelf. We should be able to use it when we want to use it.
Thank you, Mr. Joseph. Would you like to add, Dr. Kiran, to regulatory reforms?
It's actually very nicely said. Every day we see so many cyber attacks which are going through. It's really a dirty place. And for the simplest point, you can notice an email which comes out with so many backend links, which an unknown person in that field or a general public civilian faces a lot of discomfort when he or she loses money for all these simplest things. Or a startup in its budding stages loses all the entire hard work what it has done in terms of homework. So all these things, I don't want to go further in depth. As Mr. Joseph has said, it is actually a dirty field. So let's respect what is going on in that field and hope that we are all safe.
I'll add one more point here, and which is missing in our country is when we say cyber security, people think about IT security, data security. But in our sector, it is nothing. It's all about firmware level. Most of the attacks are happening through, those who study, communication layers, they understand this part. It is not at the application layer these attacks are happening. In defense network, in nuclear networks, the layers below that, people penetrate. None of our antivirus, current tools we use in cyber security will not be even able to detect it. And people are enjoying and sitting and saying, I am secure, my antivirus is not detecting anybody. Whereas someone is below your layer is Aram say, he's enjoying and he's taking whatever he wants. So this level of sensitization we need to do in defense. At least there are some people really aware of it. In earlier days when we discussed this, they said, no, man, everything is secure. I said, no, you go one layer below where we are doing. What is the layer? I said, and we showed them that, oh, really? So the awareness level is there. Now I'm seeing a lot of agencies are working in that space. I think things will improve.
Definitely, Dr. Joseph. so many plug holes are there, and we should not feel overconfident because they are 2-3 layers above than us. So, Mr. Amardeep, what are
Not much to add to what Dr. Kiran and Mr. Joseph said, rightly said. And then for us in our application, the way we see is since we are into making unmanned air vehicles, right? So security comes really more than just the protection of a company's intellectual property. It's more to do with security at the level of communicating with the machine directly. So I think that's where Mr. Joseph was going when he talked about firmware. So I completely agree with him. That's even bigger threat than the threat we're talking about with the company's intellectual property.
Thank you, Amardeep, for sharing your opinion. What achievements do you observe for the aerospace sector in terms of indigenous R&D, manufacturing, and safety?
So I'll take it in the case of R&D because
Right.
I'm close to that.
Yeah, please.
So in terms of R&D, as I said in my first submission, that we are getting a lot of support from especially Department of Science and Technology through various modes. So I see that there is a huge success rate in terms of R&D, especially in the aerospace industry, because any innovative product or any innovative idea is being supported. And they're also not only supporting in terms of funds, they're supporting in terms of how to complete the manufacturing process itself. An individual who doesn't know how to become an entrepreneur or how to make a business is being guided by all these schemes and support that they're providing. So right from skilling, right from mentoring till the financial support, everything is being provided by our government at this point of time. So I see a huge success in terms of R&D with respect to aerospace and defense sector in our upcoming years.
Thank you, Kritika, for highlighting the R&D aspect. Dr. Kiran, what collaborative or partnership prospects do you see for technology transfer in the aviation sector, domestically as well as globally?
Significant amount of technology transfer aspects are going on throughout the world currently because of the fact that, as you all know, the war scenario is going on, and intergovernmental technology transfers are of one kind. And additionally, there are also technology transfers of private organizations with private organizations. And in the whole process, what is the important point is there are also some barriers, especially in the aviation sector, about what type of engines, what type of technology can be transferred, and some sort of regulations which hinder these processes between the developed countries and India, for example, or some sort of barriers even for import, which are now being created so that the indigenization of the products in a positive way goes ahead. But effectively looking at transfer of technologies, example, if you take the case of any engines from a particular location, the effective specifications of the engine determine the possibility of the technology transfer in some cases. While on the other hand, there's also the regulations of the US, which are governed by any of bilateral treaties, which might offer in some case, or if you know the history where some sort of denial of technology was also happened in this case. So all these things are in a way going to directly or indirectly affect the actual technology which is being transferred and actual technology which is going to be used by the country in that field. So we very well say, yeah, technology transfer, but effectively what is being transferred is what is important. And how much of it is actually worth that effort is a question. So if we all of us know that we have got significant amount of technology transfer or support from Europe as well as from Russia and France, especially in the aerospace sector, if you consider the aerospace sector. But looking at the fact that we also had denial of technology a lot, where we had it from the US. And all of us also have read in the history that some cases, some technologies were even stopped, other countries to be given to India. But now we are at a point where we could proudly say that we could also give a lot of technologies to the world.
As we, becoming an export hub for defense systems, don't expect anybody will give us their best technology to us.
Actually,
Whatever is, I'm not saying useless, or probably whatever they find not adding much value in their supply chain at this point of time, that's what they could. Maybe that's a starting point.
correct.
I don't mind, taking up something from somebody, but then that is not the end. We should be investing on, as a country, today we are capable, we have the brains. I mean, everybody uses our brains. So we should use our brains for our country, for strategic objectives, and we should invest on, you take up LCA itself. Many people laugh at LCA, but I'm telling you, for safety, that question about safety, LCA never had an accident. Nobody died in LCA trials. The program I'm deeply involved. No accident so far compared to all other fighter programs across the globe. So we had the best design from a safety perspective. I'm talking about decades back. This country had. We had Maruti, the HAL aircraft olden days. So we just need to go back to our roots. We are capable people. We have now resources available. We just need to set our long-term objectives, motivate our people, be self-reliant, be proud what we are. I'm not saying no to foreigners. People sometimes mistake me that I work for an MNC. I'm proud to say that. But then I'm a Deshi. I'm a Deshi, and I'm with everywhere. I keep telling people we use our brains for building self-reliance. While we collaborate with others, most welcome. But long term, we should be able to stand. We should be able to share our technology to others also. I mean, it is not a no man's land. We should be able to help others. And like what we faced from others, we should be able to share.
Yes. Thank you, Mr. Joseph, for your lovely comments. Mr. Amardeep, what improvement do you view for using nano-material reinforced composite materials, such as graphene reinforced polymers, in transforming structural parts for aerospace applications?
Yeah. So nanomaterials, to be honest, a lot of that has been hyped for last decade and a half now, but we should be very careful in choosing what are the feasible applications and the right applications for that. Because I did my master's research in nanomaterials. Being my thesis and research spent years on that, I can say that they're great at lab scale, but when it really comes to production scale, they have to be used in like very few cases where they really make sense. Because when it comes to aerospace, or even for any industrial application, not just for aerospace, bringing something into commercialization means scaling it up from a lab scale to industrial scale with a repeated quality and reliability of, you can say like 95, 96 or 99.99% of reliability, right? So that kind of reliability achieving with nanomaterials is extremely challenging, and the benefits that they could give, even if that is achievable, is something questionable, because it does have other downsides also. Whereas there are a few applications where it makes sense, and one of the applications being more of electric conductivity and thermal conductivity than on the structural side. So on the structural side, for very small components, they still make sense and they're being used in some applications. But at least at this stage, we don't really see nanomaterials in composites to be any serious contender for major structural applications. Still, a lot of ground has to be covered. A lot of R&D has to be done. That's what is my take on it.
Probably I may add some point over there. Actually, as Amar said, any sort of application which is needed by the industry to evolve from a state of a lab scale takes significant amount of time. And the field, for example, of metals, which have been currently now taken over by the industry, has evolved itself over the years, decades of experience, what the ancestors' knowledge have given us. The same way, nanomaterials is a very pretty new field for the industry to be able to produce parts which are reliable. At the scale of sensors, already we see how many years our sensors work. At the scale of batteries, we see how many years our batteries work on our mobile phone. Yeah. So it takes significant amount of time for us to get, a product or products which are reliable, reproducible in this sector.
Thanks a lot, sir. There is a question from the Q&A box. Raw material and supply chain management is also important in manufacturing process. How do we tackle this problem to decrease the dependency on other countries for raw material? Anybody to take?
Sure. I think maybe I can take this. In fact, I was
please.
going to talk more about this in my independent talk later. But that's a great question, and that's where we have difficulty every day. We struggle day in, day out, to be very honest. So I'm into building like aircraft systems, and I was with Skyroad before, where we were building rockets, and we face this. We have achieved a lot of great things at system level and engineering level, but we still lack robust supply chains. And the solution for that is definitely having a long-term view. Most of the times, the limitation that we have is majority of even the large corporations in the country, they take very short-term view, which could be for their own reasons of, they can justify their reasons. But what I'm trying to say is, for us to really tackle this problem, there has to be few companies, be it large, be it small, whatever, have to take a very, very long-term view. When I say long-term, not 3 years, 5 years, these are like 10-year, 15-year problems. And at least few companies, if they're successful, they're going to completely turn the game in terms of building robust supply chain. So a lot of companies have to take that long-term view.
Yeah. Thanks a lot, Mr. Amar, for sharing that opinion.
In simple terms, what we can add is that increase, possibility of production of such items. Very simply and crudely said, but this sentence has a lot of things behind. Many startups, many companies have to come forward to set up such, aerospace or defense quality. It takes some time. He's very easily said, yeah, we can do it by increasing, indigenous startup, indigenous production. Yeah. Rightly shared, sir. How is 3D printing contributing to sustainable practices and waste reduction? And what eco-friendly materials are being used in additive manufacturing? So indeed, 3D printing is one of the technology which reduces significant amount of time, has a lot of benefits, but at the cost of a very critical examination, what is going behind that is critical characterization at various stages and critical qualification standards which are being set at various levels of various layers of qualification standards have to be set for that. In fact, I'll be showing some of that also in the presentation following up. But looking from the point of view of subtractive manufacturing and additive manufacturing, subtractive manufacturing is nothing but the conventional manufacturing, where a significant amount of material goes into waste. But there is also additive manufacturing where some of the supports or support structures are also wasted. But the amount of waste in additive manufacturing is comparatively less. And also the number of joints which are made in additive manufacturing are pretty less, which reduce the facts that we all have some failures over there. So that is the reason additive manufacturing has been gaining importance both in the metal additive manufacturing sector and also in the polymer additive manufacturing. In fact, by 2030, it is also prognosed that approximately around $50.6 million would be the business in the case of metal additive manufacturing sector. It's a huge rush game what people are trying to play over there because of the fact that they have flexibility to print whatever form of material in different form of customizable options according to the requirements, which might also change in the research phase or might also change in the budding stages of any company. So there are a lot of advantages there, but at the cost of critical examination. So you just can't directly ignore any of the characterization which has to be done either before or during the process or after the process.
Thanks, Dr. Kiran, for sharing the details. Kritika, how do 3D printing is shaping the future of manufacturing?
If you again take our industry in terms of drone technology, 3D printing is highly useful. So you see, in making a drone or a UAV, we don't, get lot of components inside India. So the only thing which is making the drone self-reliant is this 3D printing, to be very precise. Because by 3D printing, we can make the frames, we can make the supporting structures, we can make even the propellers that is required for the drones and UAVs. For as per our topic, for this self-reliance, this 3D printing is helping the entire UAV industry in terms of taking the manufacturing forward.
Thank you, Kritika, for sharing your opinion.
I would probably like to add one more point, especially in the fact that all of us are using 3D printing. All of us are using 3D printing in various sectors, aerospace, defense, and strategic sectors. But coming to the point of how much of that 3D printers are made within the country, we still are lacking self-reliance. And there should be a point, both from the point of view of polymeric as well as for the metal or alloy additive manufacturing or 3D printing, that we should be able to make our own 3D printers in the forthcoming years. So that would change significantly dependency on foreign, imports, and also catering to our own development of future.
That's a thought to ponder about, Dr. Kiran. So my last question is, Mr. Joseph, in current technological advancement, what is the importance of us upskilling to harness the opportunities presented by automated manufacturing?
You mean upskilling, right?
Yeah.
It is the hottest topic in any sector today. The traditional skills, people finding it a bit difficult. Now, there is a saying, now once you are 40, nobody needs you. Right? I'm in 50, still I'm surviving. But it is the scenario right now, which every person, we call it the midlife career crisis, and it is spreading across. So the only solution for that is actually, upskilling, reskilling of current workforce. And in the auto sector, it is happening in a massive way. From a mechanical car, the car is becoming a digital car, a software-defined car. And same in aerospace and defense also, from a traditional materials or mechanical-based systems, it's all about electronics and software. So we probably will have to reskill a lot of people, even in the manufacturing process being followed. Even if you really want to get into export market, we really need to have a better QMS. AS9000, that level of certifications, people need to be following it. So it needs some significant investment in terms of reskilling the current employees. It's not fair to throw away all those people, right? Government also probably need to work on some with private agencies on this reskilling area. And it is the right investment because unlike in other sectors, aerospace, I've seen in abroad, people in 50s, 60s, 70s working. It's an area which requires, in my organization, I have people in 70s and early 80s still working. Right. As the gray goes up, it's still demand. So this is one sector which actually the elders could take up a little more seriously. And maybe in abroad, many countries, they don't want to work beyond retirement. But here, anyone who has got a passion, there is an opportunity for lifetime as far as they keep learning.
Thank you, Mr. Joseph. There is an open question to panelists in the Q&A box. Can you identify any specific application for the implementation of industrial robots in the defense and aerospace sector? It's a little long. Unlike the automotive sector, aerospace in particular often deals with low volume production. I'm here representing Automotive Robotics India Private Limited, and we are proud to announce that we have recently deployed the first high-precision robotic machining system for the verticals. Messrs. Tata Boeing, Hyderabad. We would like to gain insights from experts regarding the potential opportunities for robotic applications in this domain.
First view is we should talk to Army people. They are looking for robots on the field, not small numbers, big numbers. So that's where the biggest action is happening. Maybe others can add in manufacturing space how far it will be useful. But then my first recommendation is go to field applications on actual war front. There is huge potential.
Yeah, thank you very much. Thank you all. I'm sure this initial discussion had heated the ground enough for individual submissions.